Welcome to our tech talk on GotDadJoke. GotDadJoke is a web app that helps users find dad jokes. The problem our team sees is that the world is surrounded by a lot of negative content. It is evident by any entertainment media, news of the world in trouble, or events of people simply misunderstanding each other due to the complex nature of humans causes great tension in everyday life. Our team knows that the solution we need is something that is simplistic and can counteract the negativity in the world. What better way to ease the tension than with laughter? That is where dad jokes come into play. Dad jokes are basically overly simplistic humor, all of which fits in the requirements for the solution. Also, going along with the spirit of Code Day, our team wanted to create a solution that is more than just an UI with an API attached to it. We wanted to help the users get the best dad jokes that they can get. So we dipped our toes in the water a bit. We took our dad joke. Parallel lines have so much in common, it's a shame that they'll never meet, and posted it on social media. In 7 hours, there were over 300K views. This shows that dad jokes are still needed in the world. This allows users to step back from everything in life and enjoy a good dad joke, even if it's just for a second. Welcome to the solution part of the talk in GotDadJokes.com. Given the chance, a website dads would design. Let's talk about the features right away. Right in the center, a random joke is displayed. It also contains the sentimental value of the joke represented by an emoji. Smiley face for positive, frowny face for negative, and neutral face for, well, neutral. Below that, there is a rating system for the current joke. You can select out of 5 stars. And even more below that is how many users have rated the joke. Either selecting the joke itself or the green button below, the joke on the screen will change. On the left-hand side at the top, we have a search bar, and just like most search bars, it will look up jokes, in this case, containing the key terms that is used for a search, such as dog. Beneath the search bar contains a filter function. You can filter the jokes based on the sentimental values of the joke. So if we go back to the front page, we could click here to the negative, and when we click random joke, will bring us nothing but negative sentimental jokes. And to aid the user, we added a most popular search term section on the left side, giving a list of 5 top search terms so users can click it and find the joke that they want right off the bat. As more and more users use the search function, the most popular search term will constantly update. The GotDadJoke web app uses ICANHasDadJoke API for its jokes, which is processed through our application backend.
Here is an infrastructure of our app. We are using AWS to host and run our static website. For source control, we use GitHub. We use Terraform for the infrastructure as a code to manipulate our AWS ecosystem from a centralized point. Open source modules simplify this process. We set up a remote state file that is stored securely in S3, and it allows us to collaborate and avoid conflicts. For our front-end automated CI/CD, we used AWS Code Pipeline. We created a usable Terraform module for this, which we can reuse for future projects. Our module allows us to specify the GitHub repo as a source and S3 bucket as a target. Using the AWS Code Pipeline, code will automatically update every time there is a commit in the repo branch specified. We use the serverless framework for configuration and manual deployment of the backend. Each microservice in our project consists of a serverless YAML file with Lambda and API gateway configurations. We used a custom domain name to set up API gateway routing. Serverless framework allowed us to save time on backend and API configuration, which simplified and expedited the deployment process. For our project, we chose serverless architecture that allows us to avoid backend server management and dedicate more time on feature deployment of our app. It is also a cost-effective solution that allows us to pay on the per usage of our functions. For example, the price for the Lambda function we used is only 20 cents per 1 million requests. Let's dive into our AWS infrastructure. Hosting of a static website and its resources, including HTML, CSS, JavaScript, and image files, we implemented using S3 bucket and CloudFront CDN to deliver it to end users. JavaScript executes in the browser and sends received data from the public API. Lambda functions work with GotDadJoke public API and DynamoDB NoSQL database, including AWS Comprehend. Let's look at the GitHub structure of our app. We have a GitHub organization to be able to use and control multiple repositories. Each microservice has a dedicated repo. We have front-end, where we store HTML, CSS, JS, and all supporting files. GotDadJoke API, repo, which basically a main part of our project functionality, the rating system repo, and also Terraform, where we store all Terraform files. GotDadJoke API and rating system each has its own serverless YAML file with all the configurations. Let's take a look at how our Lambda functions work.
The core of the GotDadJoke API consists of 5 Lambda handlers. Random joke that returns a random joke. Search all that returns 5 random jokes across all terms. Search term that returns 5 jokes based on a term. Search term paste returns 5 jokes based on a term, but with the capability of being paginated. Most popular that returns the top 5 most searched terms. We are using Python for the handlers that return a resource for the REST API. For random joke and the 3 other search handlers, we are grabbing the jokes from the public API. In addition, for the first 4 handlers, we are performing sentiment analysis, and in case the joke is not new, we are grabbing its sentiment values from the DynamoDB table. When the users search for a joke, we are keeping track of the search terms. We are binding the handlers to get and post methods using a serverless framework, most popular. To get the top 5 most search terms, we are scanning the DynamoDB table and using a heap to get the n largest terms based on the values of the amount. An improvement to it would be cleaning up the table by deleting the list search terms and a scheduling task to remove all terms. Sentiment analysis. We are performing sentiment analysis using the AWS Comprehend service. In Python, we use Bauto 3 module, which is an AWS SDK for the services. After analyzing the joke, we cache the sentiment along with the ID of the joke to a DB table. We then append the sentiment value to the JSON object that contains the joke that is served as a resource.
As you might have noticed earlier, we also implemented a rating system. It allows users to rate a joke, see ratings, and how many people rated it. The rating system on the backend consists of two Lambda functions that are using the DynamoDB database. Update rating Lambda function is to query database and update, add rating, and return average rating of the joke and number of times joke was rated. Get current to query the database and return the current rating of the joke and how many people rated it.
What we learned: optimization of Lambda functions in order to minimize runtime. When implementing the rating system, we tested the time spent and built for each Lambda and decided to divide it into two separate functions. The reason for having two functions that overlap in some functionality is to minimize running time of functions. When not all functionality required, then it will be more beneficial to use a function that has less runtime and as a result will save money. We learned from using serverless technology that it gives the engineers the ability to focus on feature development and code quality instead of system administration tasks and follow DevOps approach. Serverless versus serverless. At the beginning of the project, we started with a Node.js server app using the Express.js web framework. Then we learned that using AWS Lambda, which is an event-driven platform, we could have just functions returning the response objects without the need to provide routing methods for the resources. We just attach them to the API gateway, and that provides a loosely coupled architecture for our projects. We also learned how to integrate those Lambda handlers using the Node.js serverless framework, which gave us more freedom when developing in our local machines. Scanning or querying a Dynamo table versus querying a relational database. We learned that the CRUD operations in DynamoDB are slightly different from those of a relational database. The functionalities provided for this key value pair document based NoSQL didn't include capabilities of group by or order by for secondary indexes, so we did a walk around.
Let's talk about the future work of the web app. We plan to set up CI/CD for the serverless backend. In other words, connect GitHub to it. Currently, only the random joke on the front page has the option to rate. We would like the search jokes to have the same abilities. Another thing to change is to use React framework to build the interactive web elements. All of the app's behavior currently uses plain old JavaScript. Add natural language processing to the search results, something as understanding the difference between a hot dog and a dog that is hot. Searching with filters is somewhat slow. We plan to optimize the search speed and filtering functionality. In addition, we plan to optimize the top most search terms on the backend by adding a functionality that keeps the table that keeps track of the search terms small by resetting the search term counter every few hours. Come visit our project at GotDadJoke.com. Thanks for watching.